right? Actually, before we jump into that, we need to remember a few things about our units, right? We need to remember a concept called dimension analysis. So if I give you something like this, right, you have to be able to check the units on the left-hand side and check the units on the right-hand side to see if the equation is what? What's the word? Right? And how do we know? How do we know if it's homogeneous? Is if the units on the left and the right are equal. Does it mean that the equation is right? No. Right? The equation could be wrong, but the units on the left and the right are the same. So homogeneous, right, does not imply accurate, right? Right, so a quick little thing here. Right hand side is what? The right hand side is kg, and do we work with derived units? No, we work in base units only, right? So the right hand side kg velocity is ms minus 1 squared. So when you work this out, you'll get kg m squared s to the minus 2. What about left hand side now? We know left hand side joules, right? But how do we break it down? What to do? What's the alternate unit for joules? Joules is what? Right? 1 joule is what? Now, something else. Right? 1 Newton meter, right? So 1 joule is 1 Newton meter. But as I said, we cannot use derived quantities. So what to do here now? Can I break up newtons? Right? So a newton is what? Yes. Kg ms minus 2. When I multiply the m's, you'll get m squared s to the minus 2. Are they equal? Yep. Left hand side equal to right hand side. Therefore it is homogeneous. All right. But again, we know the question. We know the formula wrong because it's missing what? And missing the half, right? And missing the half. All right, nice. What's the next use of knowing the units? Sometimes you might see a question give you something like this. It gave you 20 kg. It gave you 20 kg per second. What does 20 kg per second imply? What does this say? This says what? Mass per unit time, right? Okay with that? So, for example, if you get something like this now, I set it to find force, right? I set it to find force. We know that force is something like this, right? We can see now that m on t is 20. And then all we need now is change in velocity. All right? So what we could use is we could use our units to create quantities that we could easily substitute. All right? So looking at the units is very important. Right? We could also use your SI units to derive equations. All right? Right. After this, the next thing that we need to remember is something called errors. All right? So if I give you a quantity, let's say mass, right? Mass could be written like this, 20 plus and minus, let's say 1 kilogram. This one here is our what? Is our error, our uncertainty. Right? How do you normally find uncertainty from a device? How do you normally find uncertainty? Normally what? If I give you a scale, let's say the scale is analog. How do we find the error? Half of the smallest reading. Right? Half of the smallest reading. Everybody okay with that? So half of the smallest reading would give us our uncertainty, right? And let's say now we have to find something like this. Let's say I say to find the energy, right? And energy is equal to a half mv squared. How do I find the error in E? What do? To find error in E, I have to find E using the mass and the velocity and multiply it by the fractional error in M plus the fractional error in V multiplied by 2, right? Because we have two of these quantities, so basically we're going to have two sets of errors to consider. That's okay? So we need to be able to find error and fractional error. That's okay? So the error in E is given by E, which we find by using the mass and whatever the velocity is. And then you multiply by the fractional error. That's okay? If the quantity appears 3 times, then this will be 3. If the quantity is to the power of a third, then this will be to the power of a 2. All right? All right, so some small things to remember about errors. Everybody clear it up? We'll run some questions on the way, right? After errors, where do after errors? Why don't the questions want to put you some topics, right? After errors is what? Right, so after you do errors, right? Of course, we should go a little more in depth into this, right? Let's see if we remember the 2 types of errors. What are the two types of errors? Systematic. Right? Systematic. And well, experimental or random errors, right? Right? And random errors, right? How do we make random errors smaller? Right? So we use repetition. And how do we reduce systematic errors? Close here. So why is do to fix it? Fix it? Yeah. How? So one thing you can do is you can change the apparatus. Or what else? Or we can use a formula. Right? I'll just say use common sense, add the error one all the time. Okay? So you can use a formula or you can do that. What would happen if we reduce random errors? What type of experiment we end up with? If we reduce random errors, what type of experiment we ending up with? A P word and an A word. So which one is which? Oh. Right? If we have small random error, we make it more precise. If we have small systematic errors, we make it accurate. Okay. Next thing that we need to remember on this little section here is resultant forces. If I give you a force F acting at an angle theta, right? Go ahead and write. All you have is summary, still to write these things over. So between now and reading the summary, and then you'll see it. Okay. Right. So resolving forces, right? We know that once we have a force, right, acting at an angle to a horizontal, it has two components, right? Because this force is causing the object to move to the right and to move upwards. All right. So this force causing the object to move to the right and upwards. So it means that F has two components, a horizontal component and a vertical component. How do we work out the components? Real simple. Wherever theta is, that will be F cos theta. Right? Wherever theta is next to or adjacent, that's cos, and the next will be sine. That's okay? Or we could try our next example. Right? What are the two components here? This object is moving to the left and upwards. Okay? Here's the angle. So adjacent to the angle is vertical, F cos theta. And if one is cos, the next is sine. That's all. All you have to do is figure out one of them. Right? Wherever the angle is, cos, and the next will be sine. Everybody okay with that? Nice. Once you have the components now, we need to be able to find a few things. Number one, we need to be able to find resultant force. Right? We need to be able to find resultant force. And number two, if the resultant force is zero, then what does that mean? If I give you a system just like this, if I give you a system and the system looking like this, right? If the resultant force is zero, then the system is in equilibrium, right? But how do I find the resultant force? What is do? So the first thing we need to do is resolve this, right? Resolve this force. Let's call this F1. Let's call this F2. Let's call this F3. So the first thing I need to do is resolve this force vertically and horizontally. Let's call it F4 and F5. Right? So when you resolve this force horizontally and vertically, it's no longer there. How do I find the resultant now? Add up all. Resolve horizontally, resolve vertically. Right? So it might simplify to something like this. Horizontally, vertically. Right? Resolve these two horizontally, resolve these two vertically. And now your resultant will be right. Everybody okay with that? Right? If this resultant is zero, then we know that system in equilibrium. That's all right? And we can handle more or some questions. Questions first? Ready? I think I'll make a mistake and send module 2 to somebody online, right? Check back and see. Huh? Now send somebody online by mistake. Right? I think I sent you module 2 by mistake. Check it back, it should be module 1, right? Right, your pages might be numbered on yours, but it's not numbered on mine, right? So
It's the office closing, all right? So
yeah,
you have to
everyone,
make a payment.
anybody? No? Yeah?
All right.
Go fast.
You can have both.
Right? Let's start here now. Right? Although it's terminal velocity, we can still do it because of the dimension analysis, right? Only part 1. Yeah. Right there. Open your door now. Sit very nice. We're doing this part alone. Hurry up, try that fast. Right? We have plenty of questions to do all this, so we had to work kind of fast, right? Nobody was here this morning, so let's get all the fresh. Right, well done, time up. Right, so they wanted to find the units of B. Huh? Yeah. Right? What's the SI unit for B? Yeah, the left side. MS minus 1. What's the SI unit for M? HG, nice. What's the SI unit for G? MS minus 2. MS minus 2. Yeah. What's the SI unit for 6 pi? No unit, right? We're doing okay. And what's the unit for R? meters. Right? Make a substitution time over what the unit for key. And you can do part 2 one time, you see after. Do part 2 one time now and find what is key. If we have M, we have R. Oh no. You can't do it. We do have terminal velocity. No way with that. That has a graph that you have to plot. What we can do is take turns in class and make some people plot them one by one. Right? Plot them for homework, right? Sarah, plot them for homework. Plot one, right? Right? I just making KD subject, right? So that will be mg over 6 pi dt by r. Right? Mass is in kg. Gravity is in meters per second squared. Velocity is in meters per second. And r is in m. Simplify it out. Let's see what you got. Our class is at half 6, right? No, half 7. 6. For sure.
Yes.
Right, nice. So your m's will cancel, and one of these signs, one of the s will cancel. So I got kg m to the minus 1, s to the minus 1. Will I get that? All right, nice. Let's continue. So that's the second dimension, right? I didn't give you the years, so when you do it over my student, I can see, right? I know someone that do it. Next one here. Oh wait, no, look at here. Define precision and accuracy, and then comment on the accuracy of these values. Hurry up. Let's take a look at this. Look at the values and what you think. Write it now, tell us now. Think about it, right? And they give it a true value. 3.75, right? Comment on the accuracy of the experiment, and then they ask to comment on precision. So do two of them one time. Right? If you have a bullseye, right? Just a quick question I ask you. If all your values right here, what type of experiment is that? Precise, right? Is it accurate? No. All your values close together, but it's actually far from the actual, right? Hurry up. Write your answer for part 1 and 2. Our your first exam is maths, right? I mean, physics, right? Chemistry, paper 1, it's the same week. chemistry or 1 is the fourth, and physics is what? But paper one, paper one. All right, nice. So what can we say here in terms of accuracy? It is not accurate because the value on average 4.75 is far from the true value, which is 3.75. Okay, give them an average, right? The average of those is 4.75. Okay, so it means that it is not accurate, right? But what we can say is precise because all the values are within 0.01 of each other. Okay, so it is precise but not accurate. All right. Or they could probably fix this problem. They didn't ask for how they could. We do using what? A different apparatus, right? Right? Probably the measuring probably something wrong here with the reader one. Right? So we can add a formula to cater for the one it probably off, or you could change the apparatus, right? Right? Do part C first, not part E, get part C. Right? They want the fractional error in M. They want fractional, right? Remember the example I showed you. Right? They want the fractional error in M. So what's the first thing to do? Right? Make M the subject, right? Make M the subject. So M is equal to FR all over P squared. Everybody okay with that? So what do we get? The error in M on M. Oh, sorry. So I must read the whole thing, right? Read the whole question. I just say given, right? Oh, given all of them, right? So they want the fractional error in M. Right? So make sure you read the question first, right? And that's another example of what will happen if you don't read. Right? So you'll end up with what? You will end up with the error in M on M plus 2 by the error in B on B plus the error in R on R. That's okay? That's what they wanted, right? Right, what is the next part? We'll do that tomorrow. Are you okay with it? No, they want the fractional error in it. So they want delta F on it. Okay? That's what they asked for. Right? So they want the fractional error in F, so they want that. Right? And I think that's the thing. From these set of years, right? Hold on, man. Yes. Right, so let's continue. Let's do a, because these things haven't come in a while, let's do a error calculation. All right. Policy in this way. Just do my favor and just jot on that table because the question is to find error in C. Right? Write on the table and then I'll go back to the values. Actually, I'll do the other way around. Do this first. It's not in the handout, right? This one's not in the handout. Huh? Not away with it. Just you can just screenshot, you can take a picture if you want on your phone. And I'll scroll down, right? And I will scroll down. The objective is to find the error in C. Right, you'll recognize a lot of your past papers, last 5-6 years, all you really get tested on is velocity, is movement, motion. And lots of motion and circular motion as well. Everything is on motion. But I'm just gonna do one error before I go into motion, right? But let's say half six, right? So we have time. Six of us. Half six. So I'll break six on. Another. What's the last name? Here or nothing? Oh, I'm sorry. Are you done? Right. Let's see if we can come to the table, right? So they gave you the formula. They gave you the formula BIT MC delta theta, and they want you to find error in C. Right? They gave you all the smallest equations, right? And then complete the table and find the error in C. Complete this table and find the error in C. Oh, we missed another. I find the error in C. Time plus T. Which model is hard folder? For 1, 2. 1, 2, or 3? 3. 3 or 1. Right, Salmo, there was the uncertainty in the mass. Huh? Half of the smallest reading, right? So the smallest reading was what? 0.5? No, all the smallest reading, 1, right? 10 grams? So the smallest reading is 5 grams, right? Yeah? 5 grams, right? Was the smallest reading in any thermometer? 1 degree, so you put 0.05 degrees Celsius. What is the smallest error in B? 0.2. So half of that 0.1 current. So 0.05, right? Go ahead. And find the error in C now. Giving you 2 minutes and then I'll jump in. Is it okay to work in grams to find C? Yes. Remember the unit of just being grams, right? Nothing wrong with that. Find the error and find C and then I wrote the formula there for you, right? VITS. Right? Online in case you didn't write it down. BIT, right? Make C the subject, right? So that's BIT. Right? There's one little thing I don't know if you remember. Anybody could tell me what is the uncertainty in delta theta? What is the uncertainty in delta theta? How much? 1. Not 0.5. Why? Because you have to minus the errors. I mean, you have to minus 51.8 and 28, and you have to include the errors. We don't ever minus errors, we have to add. Okay? So the error in delta theta is not 0.5, it's 1. Okay, so don't forget that here. We don't ever subtract errors, we add them. I started using those values there. I know that C is equal to VIT over M delta theta. The value for V they gave me is 9.8. The value for I they gave me here is 4.3. The value for T is 500. The value for M, 930. And the value for temperature change is 51.8 minus 28. How much is that? What y'all got here? Want to work out here? Okay, go ahead. Right, but error in C will be C by the error in V plus the error in I on I. Error in T, well, T had no error, right? And T was negligible. Error in M on M. Error in delta theta on delta theta. Whenever we divide in quantities, do we add the errors or divide them? Or minus them? Add, right? You know, ever multiply or minus or divide. What do you think? What do you got? Right. What you all got? What you got for C? 0.951. And then you have to plug in your values, right? You have to plug in your values with delta V. Right? Delta V. Delta I. 0.05 all over 4.3 delta M 5 over 930 and the error in theta 1 and delta theta is 1, right? And delta theta was this again? 20. Right, for those who are online, in case they wasn't seeing this, right? I made C the subject of the formula and I solved for C. I found the error in C and I plugged in all the errors and I worked with all the fractional errors. 0.065. Therefore, the error in C we could actually write C. C is equal to 0.951 plus and minus 0.065. Well, it will be C. So how will that be? That will be VIT, and that's be joules per gram per degree Celsius in this case. Okay. All right. Let's go quickly into motion now. Take a minute break. Right, let's start one time. One more. Actually, I didn't give you one of these. Huh? I didn't give you a result in it. I'm gonna give you one that is different to the circular motion. Right, you want favor? Fast. Find the resultant force here. Find the resultant force there, right? Once in equilibrium, we'll see them in circle. Right, I have $3, $4, get pretty well. Right, find the resultant force of that system. So we have an object, three forces acting on it, find the resultant force. Right, what you all got? Huh? 1.3 and the angle. Remember the vector. So you need the angle as well, right? So first thing first, we can resolve here. This will be 2 cos 30. And this will be 2 sine 30. I like to rub it off so people don't get confused with it, right? Then find the resultant. The resultant here is 1, here is 3. So that will be 2 Newton downwards. Here is 4, here is here. So it will be this way. Yeah. 4 minus this is how much? 4 minus root 3. Yeah. I know what you can adjust. Anyway. All right. And then you want to find the resultant force. You want to find the resultant force. That's the square root of 2 squared plus 4 minus root 3 squared. How much is that? I pray you that's it. How much is that?
2.02. Yeah.
Right, we also need an angle. We need an angle, right? So you're adding the angle there. Alpha will be tan inverse 4 minus root 3 all over 2. How much is that? You must have an angle, right? Because it's a vector, right?
So 40.
Let's take a look at motion now, right? So that's the way you find the resultant force. If on the other hand, this question was in such a way that it was in equilibrium, equilibrium means that these two will be equal, these two will be equal. That's okay? Are you okay with this? 3.02? Yeah? All right. Next stage, we want to take a look at motion, right? So when we talk about motion, yes, we had to look at all the equations of motion and thing as well. But we want to talk about the three most important quantities. We want to talk about displacement, velocity, and acceleration, and how they're all related, right? So the first relationship between these three that we should remember, well, of course, we need time, right? The first relationship is V is equal to U plus AT. It shows us here that acceleration is V minus U1T, right? We know acceleration is change in velocity and time, right? And then we have our first equation of what? Equation of motion, right? Whenever you're using the equations of motion, I want you to remember that, let's say the object moving like this, right? We have an object moving with a speed U, then it accelerates A and cover distance S, let's say, in a time T. I want you to remember that if you want to use this equation of motion, every single thing must be in the same direction, right? This only works for straight line motion, and it has to be in the same direction. So if everything moving horizontally, we need horizontal final velocity, horizontal initial velocity, horizontal acceleration. Everything must be in the same direction. That's okay? If on the other hand, the object moving vertically, then same thing. We need displacement vertically, we need initial velocity vertically, we need final velocity vertically, we need acceleration vertically. All right? So these equations I'm going to list out have to do with straight line motion, and every single quantity must be in the same direction. That's okay? So this is your first equation of motion. Your next equation of motion, S is equal to half U plus V by T. Hardly ever use that, right? Then we also have V squared is equal to U squared plus 2AS. Of course, the obvious way to use this is if you don't have time and you have the change in velocity and acceleration. Right? Next one. S is equal to UT plus a half AT squared. All right? So those are the equations of motion that you need to learn. Everybody okay with that? Right? What you recognize about equation 1, equation 3, and equation 4? What they all have in common? Huh? They all affected by acceleration, right? They all affected by acceleration. So equation 1, 3, and 4 are all affected by acceleration. What does that mean? This implies we can use for vertical motion. Right? We can use them for vertical motion because vertical motion, the acceleration is G. All right? Any question that has to do with vertical motion, then right? I'm going to show you a nice little example here. Right? We have a little fellow here, fed up with his cape life. Right? Fed up with his cape life, so he run off here with a horizontal velocity, with a velocity of 4 meters per second. And he's a man going and hit somewhere here, right? Alright, ready? So watch this here. Let's say we have this person. He on top of cliff 2 meters high, and then he ran off the cliff at 4 meters per second, and then he hit point B. Right? No more key. So he got 0. Right? How are we going to find his final velocity? The time taken for him to hit B and R. Right? So the first thing we could probably do is try to list these things out. Right? So we know initial velocity. Whatever velocity is this? Horizontal length. So his initial horizontal velocity is 4. His initial vertical velocity is what? If you're moving horizontally, do you have any vertical velocity? No. So his initial vertical velocity is 0. This 2 meters is his what? Is this displacement vertically? Yeah. So I'm using view vertical, right? What else we know? That's it? That's all we know? So let's try part 1. We want to get vertical velocity just before you hit here. Any equation we could use? Can we use equation 3? We want to find V. We know U is 0. We know A and we know S. Right? What would A be? Right? He going down, right? So his acceleration will be gravity. Right? 9.81. So his vertical velocity, we're using V squared is U squared plus 2AS. Right? This is vertical, vertical, vertical. Right? So his vertical velocity, this is 0, acceleration is 9.81, and his displacement is 2. Right? So y'all see how we use the equation of motion? Every single thing here was in the same direction. So we get in V to be the square root of, what's that? There's 4 by 9.81. 6.3. Everybody okay with that? Emma? You okay with that? So that is your vertical velocity. Now we need to get the time it takes to reach. Yeah. We need to get the time it takes to reach there, right? So what do you think, Nathaniel? Which equation we could probably use to find t? Which equation we could probably use to find t? Time taken to reach here. First one, okay. You have final velocity, you have initial, we have acceleration if you find for t. Or we could use last one as well. Anyone could work, right? So let me use first one, since you say let's use the first one, right? I keep writing this to remind you everything in the same direction, right? What was the final vertical velocity? 6.3. Initial, 0. Acceleration, 9.81. And we can make t the subject of the formula. Yeah? So t is 6.3 over 9.81. 0.64 seconds. Nathan, you okay with that? Last part, Nathan. They want us to find R. R is a what? Horizontal or vertical or what?
Horizontal.
Right. So R is like a horizontal displacement. Which equation you want to use? Huh? 2. All right, we could use 2, right? Or we can simply use speed as distance on time. Speed as displacement on time, right? So we can find S. S is equal to V by T, right? But what's the horizontal velocity? What is the horizontal velocity? Time is 0.64. What's the horizontal velocity? the horizontal velocity is, right? Two point five. So why did I show you this? The reason I show you this, Clara, is to show you that the part here is what? When this guy jump off, is he going to fall in a straight line? No, he's going to fall in a parabolic path. So what I'm trying to show you here is that any projectile motion question, you could solve it using the equations of motion. That's okay? So by using the equations of motion correctly, you could solve any projectile motion question. All right? So the key is to master using this. All right? But I still want to show you this is like a little proof to show the path parabolic and so on, right? So let's take a look at that. So in a sense, to show you the example of showing you here is how they fuse both of them, projectile motion into equations of motion. Right? Once you use the right quantities, you're good to go. Right? So if you use this equation of motion, just make sure every single thing is in the same direction. Okay? The direction important, right? Right? The reason I confused number 1, number 3, or number 4 to solve part 3 was because I had no horizontal acceleration. Right? Right? But of course, as I say, I could have used 2 and 3. More so 3, right? Sorry, more so this version, right? So I want to show you now how to do everything in projectile motion, right? I'll leave in this here. Anybody writing this? So I'm going to use this same as something just like this to show you how an object follows a parabolic path, right? If I were to shoot this object up in the air like this, with an initial velocity u at an angle theta, the path the object will follow is something like that. You okay with that? You sometimes have to be able to prove that the path parabolic. Sometimes you have to find the velocity here, right? Sometimes you have to find the vertical displacement here. Sometimes you have to find the horizontal displacement there. You have to find all those things, right? And again, to find any one of those comes from using these equations of motion. All right? So your first step to find, first thing you do with this u, because it's at an angle, we're not using anything at an angle. We are either using a horizontal velocity or a vertical velocity, right? So the horizontal velocity in this question here is u cos theta. So we know the vertical is u sin theta. Everybody clear it up? So we know initial horizontal, initial vertical, right? Suppose I want to find the velocity up here now. To find the velocity up here, I need the two components. I need the horizontal component and the vertical component, right? Joseph, the horizontal component, is it affected by gravity? No. So throughout this entire journey, the horizontal component stays the same. So at any point in time, it has the same initial velocity, right? So that component staying the same all the time. That's the reason why I use 4 here. That's okay? Now, the vertical velocity, the problem with the vertical velocity, it is affected by acceleration. So therefore, I have to consider one of these here, right? So how do I find the vertical velocity? I could use this, or I could use this. It doesn't really matter, right? I could use any one, right? Let's say I use this one here. Vertical velocity will be initial vertical plus acceleration by time. Should this be a plus or a minus? Because they're going upwards, right? That'll be a minus. So that is my vertical velocity, right? Or I could use this version here, right? Or I could say vertical velocity squared is the initial vertical velocity minus 2as. Okay? right? So at any point in time, I could find V, all time V. So I have the horizontal and vertical component. All find the V. Pythagoras, right? Square root. So to find V, I just need to find the resultant of those two. Nice. How do I find X and Y now? X is you. What is this? How do we find X and Y? X is the what? Horizontal displacement, right? And we learned that horizontal displacement is what? Is horizontal velocity by time. Are you okay with that? Yep. So what is horizontal velocity? U cos theta by t. Right? How you find y now? How you find vertical velocity? How you find vertical velocity? This one here, right? Number 4. So vertical velocity will be the initial vertical velocity by time minus a half gt squared. Right? So you can make it look a little bit nicer. This is u sine theta by t minus a half gt squared. Yep. One more thing you just have to be to do. How do I show that y is a quadratic? How do I show that y is a quadratic? I have one more thing. How do I show that y is a quadratic? I'm almost there. I have one more thing to show. Huh? Yeah, that's it. Yeah. Replace t with x, right? So if I make t the subject, I'll get x over u cos theta. And if I substitute that in here and here, what you will get? You will get a quadratic. Okay? Okay, so these are the little things that it could ask you. How do you right? How do you find maximum height? What happens at maximum height? Zero what? Zero velocity. So at maximum height, your velocity is 0. Right? So if I put v as 0 in here, I can find time to reach maximum height. If I put v as 0 here, I could find maximum height in S. Anyone could work. V squared? Yeah, but that comes from this thing proof here. Yeah, provided the part exactly like this. Provided the part exactly like this. Because remember, sometimes the part could go up and come down quite down here. Yeah, trouble? No, and not. Yeah. This one? That is this equation here. Vertical velocity squared is equal to initial vertical squared minus 2as. Minus 2gs. Right? Let's continue with some motion and then touch some question. Right, I didn't do them out. Very okay with that? Right. Okay. Take a little minute and then let me just talk about two other special cases of motion and then some questions, right? So since we kind of on vertical motion, right? What's a special case of vertical motion? Huh? Begin with T. Terminal velocity. Right? So sometimes we could have a person or object falling with terminal velocity. Right? Terminal velocity occurs when what? When all the forces acting, the resultant is what? 0. So if I have a person here, what would be the forces acting on him? Weight. Well, when I right up thrust, one more force as he falls. Drag force. Right? So these are the three forces acting on him. Right? And if the resultant force is equal to 0, then up thrust plus drag force is weight. And we learned from Newton's second law, if the resultant force is 0, acceleration is 0. Right? And if acceleration is 0, then and the object falling, then V is constant. And we call that V terminal velocity. Right? How will a velocity time graph look like for something like that? Right? So like that, and then begins to taper. That value there is your terminal velocity. Right? So the person is falling, don't forget that. The person is falling, but he's falling with terminal velocity. Right? All right, let's see if we can apply a few of these now. Right, so we're gonna do that graph question, right? Thank you for the good that. Oh, what are you gonna do? No, I don't mind what you do there and I know they replicate it. I don't. No, I mean like what they could replicate it, for examples.
Rewrite the example.
Rewrite the example. Huh?
Yeah.
Do that for tell us exactly what coming. And then write a little paper, one in the example, another paper, and the submit this in paper. That's smart. All right, let's take a look at. Let us take a look at. Some questions there, right?
Start here.
Who?
It's like important. It's for the light of the input.
Right, the problem here is we need this graph to do number one, right? Right, we need the graph to do number one to explain. Right, remember, after we do these past papers, then I'll be at the question, these past papers, that's the questions we do it in a week. Those are doing that. We'll never see them. Right, let's jump straight into this now. I think we did B already. State the meaning of each term on the right hand side. Right? This formula is drag force. Right? I know I didn't discuss it, but let's talk about it now. Right? FD is drag force. Write down the formula. I'll help you out. Write down the formula. Huh? Is that drag force? Right, so 6 ampere just constant. R is what? R is the radius, right, of the spherical object here. The drag force not spherical object. So R is the radius of the spherical object. B is the what? It's a long elongated head. Right. Yes. R is the radius of the sphere. V is the velocity, and N is the viscosity of the medium. Just can't remember. Yeah. What is that? It up. It up. You can't remember. Whatever name, whatever ether. Come on, ether. All right, nice. Right, you have radius, you have the viscosity, and you have V, right? State the meaning. Right now, I'm not asking you to plot it, but look at the table. Look at the table. What looks like the terminal velocity there?
4.4.
Sorry, let me show you the units, right?
4.4.
4.1. Right, just make a note of that, right? Well, you can do all those quick a quick sketch in your book. Right? Do a quick sketch in your book, starting at 0, going up to 4.1 and around 2.8 seconds. Huh? Let's do a quick little sketch. Velocity time graph. There's one less way to go and use ChatGPT. Unlimited. You want to 2.8, right? Look it up. Next one here. Explain the shape of the graph. We can handle that, right? Use the graph to find terminal velocity. We can handle that. Use the graph to find terminal velocity. We did part D already, and yeah, we did part D at the beginning. Nice. We'll go on part 2 now. Part 2, D and E. D and E. Take all this week.
So you limit and
Well, you can see everything that's in it. Well, you ever get graphs where you have to linear, right? It's like take log term with type something. In unit 1. Unit 1. Physics. Can't remember. I know unit 2 for sure if you're relevant. Everything all together, one big sphere, right? Zero, one. Right, what's the part two? Right, pay attention. If the question gave you 9.8 or 9.81, right? Right, we said terminal velocity was 4.1, right? Rearrange, tell me what you get for T. What about T? How much? Maria's got that, 1.58. No? No, didn't get it. What's that again? Maria's got that, 0.65. What do you got? I have a calculator. Okay, this man telling me you're wrong too, right? 0.63, like 65. What's the units again? Kilogram per meter per second. Yeah. Take it back and make sure, right? Second part two was that. Let's take a look at part three. Part E, I mean part E. Do part E, please. I'm taking this off, right? Look at part E. Right? Think of what will happen if the radius is doubled. And then what will happen if we use a different metal? Right, so let's start with part one here. So if the radius is doubled, what will happen? Okay, more obtrusion means that you have to tell what? So the terminal velocity is slower, right? That's okay? How much slower? Huh? Half. Right? So it will move half as slow. Half slower. Right? So, and the reason that will happen because the upthrust on the object will now be larger. Okay? The upthrust on the object will now be larger. Together with what? What else will also be larger if the object is a bigger radius? Drag force, right? Drag force will also increase. Okay? What would happen if it's made of a metal of a different material? What will the different material change? Will it change the radius? Mass might change, right? So if the mass is larger, what will happen? It will go down faster if the mass is larger, the weight is larger, so it will move faster, terminal velocity will be higher. And if the mass is smaller, what will happen? It will take longer, right? So you have to consider both cases, right? Where the different metal has a larger mass and smaller mass. Right, let's go again. Right, wait, part F. Answer part F for minute, I'll say now. Answer part F, please. There's it here. Part F, ignore this. According to our Kinematics principle, when a body is immersed in a fluid, it experiences an upthrust. Explain why the upthrust is neglected in calculation for terminal velocity here. Why is upthrust neglected? Why is the upthrust neglected? Upthrust is what? Huh? Same question, Carter. Why is the upthrust neglected? Why would you neglect something? If it don't matter, it's real small, right? Right? So the reason why the upthrust is neglected is the way to find upthrust is what? Upthrust is weight of fluid is placed, which is density of fluid by volume by gravity. Right? So you may remember this 1.5, you may not, right? If the density of the fluid is very small, then upthrust is what? Upthrust is small. Okay? So the reason why the upthrust was neglected was because the density of the fluid was small, making the upthrust negligible. Right? The density of the fluid was small. Right? Always remember your formulas, that's all, yeah. Everything hidden in there. Let's go right underneath. Let's take a look at this projectile here, this guy playing football. Missing anything? Huh? These papers is 21, 25. Yes. So it's probably 4 or something. Yeah, don't mind. Let's work it out. Right? So we see him projectile, right? Right? We see him projectile motion there. Just pull me document up, please. Oh, I've been outside. Huh? I don't know when to join. So during a football match, they give you the angle 25 degrees. So this angle is 25, write it in. And they give you a velocity of 20, 30. So on your diagram, you should have all of this, right? You should have here as 25 degrees. you should have here as 30 meters per second. So everything we're going to do is one go on here. Right? Right here? Right as here, first part here. So ignoring air resistance and the rotational ball, so we're not considering air resistance and that the ball actually rotated, right? Assume that the ball leaves the foot at ground level, calculate the vertical component of the ball's velocity, horizontal component of the ball's velocity. How are you doing that?
Same still. So still horizontal. It's just that time.
Hold on, eh? The horizontal component is what?
It was double.
30 cos 25, and the vertical component is 30 sin 25. Very good. Find the time taken to reach the maximum height. What happens at maximum height again, Daniel? What happens at maximum height? So when an object reaches maximum height, what is happening there? What is zero? Velocity is zero. Hurry up. Work it out. They want the time to reach maximum height and they want the maximum height. Do that fast. Wait, Adrian. Can you sign anything? Anything? Oh. Adrian is. Okay. Whatever, pedal pencil.
Yeah.
But I'm mechanical pencil.
No. Okay. I must be right, but I. I yeah.
None. I see, I'll take it. Right. Yeah, again, anyway, problem. Ahmed, which Ellingtons. Grade one, two, yeah. You're done? Anybody confused? So I can handle it? Question. Find everything already?
All these questions are the same thing.
When you still have to work it out. You want the answer? No? So you're okay with part 1 and 2, right? So part 3 now, they said B is 0, right? Which equation in motion are you going to use? You have initial vertical, you have initial horizontal, and you have the final velocity V. Which equation are you going to use to find T? First one, right? V is 0. You know what is UH? Acceleration is what? By going upwards, right? So that's minus 9.81 and then solve for T. Okay? And then once you have T, you can figure out what to do for the horizontal, for this height here. Right? You can use any one estimate. Okay? So you use an equation 1, part 1, and then figure out parts. Next part, you can use 3 or 4. Because you want to find first. Right? That part, I'm telling you. Right? Not wrong, but too much. Yes. Right after you find max height, what else for after? Find the equation of trajectory and show that the motion is parabolic. What are you doing there? What are you doing for part E? Yeah. Right? Part E is one goal. Part E, you have to do all of this here. Okay? Part E is where you have to find X, you have to find Y, and then substitute T. Okay? So you have to finish up that. Let's check the values out first now. They want time, so you all said we could use B is equal to U plus AT, right? Final velocity is 0. Next one was 25 plus what again? Or 30 plus 25. Right? Is yeah, sorry. That was 30 cos 35 because everything must be vertical.
25.
Minus 9.81 by T. So T is equal to 30 cos 25 all over 9.81. How much? 2.77. Come on. 1.29. I know I listened to earlier. I don't know how. I don't get my calculator. Right? 30 cos 25 divided by 9.81. 2.77.
Same that we are.
Why no? I just listened to earlier.
So you tell me how to.
If I was watching, I hear them go 1 point.
I see a point something.
We are point and I'm 1 point something.
Where? I don't think.
Are you okay with that? 2.77. How come I get 1 point or something then?
Side as well.
And vertical is what? Yeah, that's correct. Vertical is what? Oh shucks, I write the wrong thing.
So I think exactly.
I write the wrong thing. I rub it off. Sorry. I rub it off. Sorry. 1.29. That's my fault. I rub it off. And what's my rub it off? What's your rub it off, right? Right, so that's the time 1.29, and then they want to find maximum height. So I could use b squared is equal to u squared plus 2as, or you could use s is equal to ut, right? And b squared was 0, U squared is 30 sine 25 squared. Gravity is 9.81 by S. So I have 30 sine 25 squared all over 2 by 9.81. If you use the next formula, S is equal to UT plus a half AT squared, that could also work, right? For which one? S? 1.67. Anybody use S is equal to? Yeah? How much you got? Same thing? 8.19? What do you use for U? Right? That's 30 sine 25. T is what? Minus a half by 9.81 by. I didn't get it. And what this one is here? 30.
Sine 25 squared is 160. We divide that by 2 by 9.81. Number 8.1.
What's the final answer? 8.19. What's your got for part? S is what? 8.19? 8.2? Who tell me 1.67? Quick question. Quick question, right? Suppose I wanted a next way to find T. What could I have done? Yeah, next way to find T. Yeah, I can use formula 4 and S as what? S as 0. And then divide the answer by 2. Okay? Right, let's go again. Any questions there? Finish off party here. You'll take complete party. Okay, then do party. Do party fast now. Party, look at it, it's still right here. All you have to do now is substitute it out. Jordan, you're okay with parts up until party? Right? Part E is the same thing right here earlier. All you have to do now is to make a substitution. Part E is where you have to make a substitution and you'll get y is equal to u sine theta by x over u cos theta minus a half, well, I'm putting it g here, right? By x over u cos theta squared. The usual cancel, so I'll get y is sine and cos tan x, right? If you write sine theta and cos theta, this is not pure math. Those still give it the mark, right? All they want you to show them is that a quadratic you end up with. All right. So if you write sine and cos, that's okay, right? And then when you square this out, you'll get g over 2 u squared cos squared theta multiplied by x squared, right? If you rearrange this, you will get a quadratic ax squared plus bx plus c, right? This is your a, this is your x squared, there's your b, there's your x. That's okay? So this here shows that it is parabolic. And you could also show them that since a is less than 0, it's maximum. Right? So it's shaped like that. Right, so add it into your solution there, right? Let's try this one here now. Last one. All the rest is circular motion, right? And then we're done. No. And we have still have process. Six. Let's try this one here. Are you sure? Take a look. Oh, yeah. Read it. Draw a little diagram if you need to. Do everything you can still you can leave it up, right? Good job, Nathan. Draw a diagram, draw your two diagrams, and then see what will happen. Right, so those who doing applied, there's an applied in the two question. There's applied in the two. Okay. Yeah, somebody. Yeah, so pick it right there. When you get all ones answer, what you can do. You what?
I'm being serious.
Oh yeah, try this now. Right, let's get a diagram and then let's define acceleration.
You told me online for like
So in an experiment, an object of mass 0.5 kilograms was placed on a frictionless surface inclined to the horizontal, right? That's your horizontal, that's your frictionless surface. Right? Let's assume the object is a block, right? This is 60 degrees. Right? Draw everything and then find the acceleration. I'll do that now. Right. I don't see why I have two levels. Right? But here's what they want, right? What will be the forces acting on the block? Gravity is now a force, right? So weight And what's the next force acting on the block? Huh?
Friction.
And the friction is fluid.
The planet. Wow.
Not yet, nah.
Interest.
That's pretty bad. So,
We just use Newton's third law.
No.
Reaction force, right? Reaction force, which is perpendicular to this. That's okay? Right, but if I leave the block like that, right? Will the block stay there? What would happen to the block? It will start to what? It will start to slide down. So it means it'll have an acceleration acting downwards, right? And from Newton's second law, if it has an acceleration acting downwards, it should also have a force. Anybody can tell me what that force is? What is the force causing it to slide down? Technically, yes, it's weight, right? But weight acting vertically downwards here. But because it's at an angle, it has two components. One here and one here. Right? If it's the first time you see it in your life, the one that's going down the plane is always W sine theta. The one that's perpendicular to the plane is W cos theta. Because if here is 60, here is also 60. Okay? So that's adjacent, and the next one is sine. That's okay? Right? See if we can find acceleration now. They wanted to find the acceleration of the object as it's going down. Right? So what's the formula more than likely I think you're going to use to find A? A is equal to what? What y'all think? A is equal to what? F1M, right? That's all we really have, because we have no velocities and things. Do we have M? Do we know the mass of the object?
Yes.
So what is your goal? Your goal is what? Yes, figure A. Right? Your goal is to find F. What is the force that creating the acceleration? From Newton's second law, we know that the resultant force is m by a. Right? So what is the force that gives it the acceleration? All right, try quick. Try something. Give me 2 minutes. What is that force? Right, you use she has 9.81, right? Right, Nathan? So Nathan, what is the resultant force that giving you the acceleration? Well, I don't know what is 4.25, but you mean this here?
Yes.
Right? W sine theta, right? So W is 0.5 by sine 60 all over 0.5. Now cancel, so you'll get 9.81 by sine 60, which is how much? How much? 8.5, which is 8.5 meters per second. All right. What would have happened if that's friction earlier?
Let's see, please.
What would have happened if that's friction? Well, what would the next force after adding here? After adding friction, right? If it's sliding down, friction is where? Friction is along the plane, right? Does it up, right? Along the plane, right? Upwards, right? Along the plane. Friction is mu r. You all remember that? Friction is mu r. Right? Coefficients of friction by r. Right? So, Naveen, what would have been the resultant force then? Suppose I had this scenario now. What will be the resultant force? Take away the friction. Very good. Right? Take away the friction. Right? Remember, friction is mu r, right? Right. Mu is the coefficients of the surface. Don't give it. Which is the same as that. No, that's in also. Wait, you don't read it. Well, you didn't read that. All right, so that is that. The next thing that we had to look at is right, momentum and impulse and thing, right? But for this one, I'm going to for it. Right, so tomorrow we will read through that and we start to do so. All we have to do is that circular motion energy. Most popular is circular motion.